In this problem, which appeared in JEE Main 2020, we have to find out the probability of getting omega to the power R1, omega to the power R2, and omega to the power R3. The sum should be 0, where R1, R2, R3 are the outputs, right, when a fair die is thrown 3 number of times. And what is omega? Omega is the cube root of unity, but it's a complex one. So let's go ahead and solve this particular problem. So here it says that omega is the cube root of unity, right? So here we say that let omega be the complex root of complex cube root of unity. That is, omega must be the solution of, must be the solution of the equation x is equal to cube root of 1, or in other sense, we can say that x cube minus 1 is equal to 0. Now, if I factorize, we can easily say that x minus 1 multiplied by x squared plus x plus 1, and that's equal to 0. Now, omega here is not equal to 1. It is provided. So that's imply that omega is the root of that quadratic equation x squared plus x plus 1, and that's equal to 0. Now, as omega is a root, we observe that omega squared plus omega plus 1 is equal to 0. And as it is a root of x cube minus 1, so therefore also we can say that omega cube is equal to 1. Now, as omega cube is equal to 1, so therefore omega to the power 3k, where k is integer, that also be equal to 1. So therefore, if I multiply that first equation, that omega square 1 and all that, by omega to the power 3k, we can write down that omega to the power 3k plus omega to the power 3k plus 1 plus omega to the power 3k plus 2. That's equal to 0. That's it. So therefore, see that here as omega to the power r1 and omega to the power r2 and omega to the power r3 equal to 0. So therefore, so it is given that omega to the power r1 plus omega to the power r2 plus here omega to the power r3, right, is equal to 0 given. So therefore, it is possible that R1 must be in the form of 3k, R2 must be in the form of 3k plus 1, and R3 must be in the form of 3k plus 3. Sorry, 3k plus 2. Now, what is R1, R2, R3? So here, that R1, R2, and R3 are the number appeared on the dice, appeared in the dice when a die is thrown 3 number of times. So therefore, that R1, R2, and R3 must belongs to the set of 1, 2, and so on up to 6. Because that is only possibilities. So if R1, R2, R3 lies between that, so therefore for k equal to 0, because here k is integer. So for k equal to 0, this value is 0. That is not possible because k cannot be 0 for k equal to 1, right? It will be 3 and 6. That's the possibility of choosing R1. R2 can be chosen like 1 and 4. K equal to 0, 1 and 1 for 4. Okay, that's it. For R equal to 0, it is 2 and 1. K for 1, it's 5. That's it. Now here we can say that therefore each R1, R2, R3, right? Each R1, R2, R3 can be chosen or can be selected in three ways. So each of the R1, R2, R3 can be selected in three ways. So that we observe from this particular problem. Now let's go ahead. So up to now, we observe that let A be the event so that omega to the power R1 plus omega to the power R2 plus omega to the power R3 is equal to 0. Now, therefore, if I try to find out what will be the total probability, right? So to find out that, first we need to find out the favorable event, right? Now see that R1, R2, R3 can be chosen or can be selected in two-way each that we just discussed earlier. Two-way each, right? From the set of, right, that 3, 6, 1, 4, 2, 5 and all the stuff, two each. And after one such selection, after one such selection, this three chosen number can be rearrange themselves in factorial three ways. Now, what that mean? Suppose I choose R1 is equal to 3, I choose R2 is equal to 1, and R3 is equal to 5, right? Because we know that R1, R2, R1, already we proved that R1 can taken from the two set, right? That 3 and 5. I just note down. So R1 can be selected either 3, 5. R2 can be selected from 1, 4 that we discussed. And R3, we decided that we will choose from 2 and 5. That's it. So if I consider R1 equal to 3, R2 1 and all the stuff, that's okay. So therefore, omega to the omega cube, omega square and omega to the power 5 is equal to 0. Okay. Now after selection, right, someone can choose that this is 5, then 3, then 1, then maybe it will be 3, 1, 5 and 1 and like that. So all possibilities can happen, right? So that we wrote, right? That after we get a selection like 3, 1, 5, they are allowed to change as factorial three-way. If someone choose instead of 3, 1 and 5, someone choose 3, 4, 2, right? Then they will also arrange in factorial three ways. So that's the concept. So therefore, with this logic, we are able to find now the total number of favorable event, right? The main one component to find out the probability. So therefore, we can write down that. So the total number of favorable event, total number of fab event, or we can write favorable. I wrote it as fab. For favorable event is equal to 2 into 2 into 2. So these are the ways to selecting R1, R2, R3 each multiplied by factorial 3. So if I go ahead, this is 8 into 3, that is factorial 3. So 8 into 6, and that is 48. Okay. Now we need to find the total number of events. Now as as a fair die, as a fair die thrown three number of times, as a fair die thrown three number of times, so thrice. So total event will be directly 6 cube, right? 6 to the power n, so 6 cube, it is 2, 1, and 6. So the required probability of A will be 48 divided by 216. So therefore, 6 can be cancelled, so 8 by 36, now 2 by 9. That's it. So removing the common factor, we obtain that option C for this particular problem is the correct answer. And that's it. Hope you understood this problem. Thank you.
Like, comment, and subscribe. Like, comment, and subscribe.